Today, we're diving into the world of Arduino, a small but powerful microcontroller that lets you bring your electronic ideas to life. I'll show you and us how it works, what it can do, and guide you step by step so even beginners can follow along. By the end of this video, we'll understand exactly how Arduino turns your code into real-life code actions. So, without further ado, let's get started.
The Arduino Uno R3 is a microcontroller board based on a removable dual inline package or DIP at Mega 328 ABR microcontroller. It has 20 digital input and output pins, of which 6 can be used as PWM outputs and 6 can be used as analog inputs. The prototyping shields make it easy for you to design custom circuits. You can solder parts to the prototyping area to create your project, or use it with a small solderless breadboard to quickly test circuits ideas without having to solder. A jumper wire is an electric wire that connects remote electric circuits used for printed circuit boards. By attaching a jumper wire on the circuit, it can be short circuit and shortcut or jump to the electric circuit. A resistor is a passive two-terminal electronic component that implements electrical resistance as a circuit element. In electronic circuits, resistors are used to reduce current flow, adjust signal levels, to divide voltages via active elements, and terminate transmission lines, among other uses. A 5mm LED is a light-emitting diode that has 5mm diameter at its round or flat lengths. Like all LEDs, it has two legs. The anode, longer leg, connects to positive. The cathode, shorter leg, connects to negative. Push buttons or switches connect 2 points in the circuit when you press them. This example turns one LED when the button pressed once and off when pressed twice.
Hello everyone, my name is John Stephen D. Saigon, and today I'll be the one to explain how this code works. So, this Arduino code controls a simple traffic light system with a pedestrian crossing button. Firstly, in the declaration part, the variables car red, car yellow, and car green stores the pin numbers for the car traffic lights, while ped red and ped green stores the pin numbers for the pedestrian lights. The variable button stores the pin for the pedestrian button, and cross time sets how long pedestrians can cross. And lastly, change time will store the time when the lights last change. Now, in the setup section, each pin is set as either an output for the LEDs or input for the button. The car's green light and the pedestrian's red light are turned on at start to indicate that cars can go and pedestrians must wait. Now, however, in the loop section, the Arduino constantly reads the button state. So, if the button is pressed and at least 5 seconds have passed since that last change, it calls the change light function. Now, inside the change light function, the car's green light will turn off and the yellow light will turn on for 2 seconds, then turns off as the red light turns on, stopping the traffic. Now, after a short 1 second wait for safety, the pedestrian red light will turn off and the green pedestrian light will turn on, allowing pedestrians to cross for the set cross time, and then the pedestrian green light will blink for 10 times in a constant motion of 0.25 seconds on and 0.25 seconds off as a warning before turning the pedestrian red light back on. After that, the car red light will turn off and the yellow light turns on for about 1 second. Then the car's green light turns on again, allowing cars to go. And then finally, change time records the current time so the button can immediately trigger another cycle, and the system returns to the main loop to repeat the process.